Hey everybody, in this video we are going to be going over section 4.3 exercises. So this is the beginning video, questions 1 through 5. And we are going to start off with exercise 1, which asks us to describe, so explain how to solve x divided by 3 is less than negative 2. So this is a division problem. And because it's a division problem, that means we can either only use multiplication or division to solve it, because multiplication and division are inverse operations. That means that they are the opposites of one another. So for example, multiplying something by 1/2 is the same thing as dividing it by 2. Let's just pick any number. 1 times 1/2 would equal 1/2. 1 divided by 2, or 1 over 2, equals 1/2. And so that's how you can see that they are inverse operations. You can use multiplication and division to get to the same answer. You just have to use the reciprocal of them. This 1/2 here, when we multiplied by it, turned 1 into 1/2. And then the reciprocal of 1 over 2 is 2 over 1, or just 2. And dividing by 2 gave us that same answer, 1/2. And so that's what we call inverse operations. When you can do the same thing, when you can get to the same result using different operations, we call that an inverse operation. So what we need to do in these types of problems in section 4.3 exercises is that we need to take a look at the inequality and determine what operation do I need to use in order to solve for x, in order to get the x by itself and figure out what solution set works for x. So is x less than 7? Is it less than 5, 10? That's what we're trying to figure out. Well, for this one, because we're starting off with a division operation, we want to get that x by itself by putting a 3 above with the x, because that's going to give us 3 over 3, cancels it out to equal 1x. So how do we get a 3 above with this x to cancel out that 3 on the bottom? Well, we can multiply by 3. Multiplying by 3 is the same thing as multiplying by 3 over 1, which equals 3x over 3, exactly what we wanted. And 3x over 3 just equals x. And so that would give us x is less than, and then we would do the same thing to negative 2. If we multiplied by 3 on the left side, we're going to multiply by 3 on the right side, and 3 times negative 2 is going to give me negative 6. So we get the answer that x is less than negative 6. And that's not what we're being asked, though. Now, using that kind of technique, using what I just did, what I just showed you to solve this out, you are going to be answering this question. Explain what we did to solve this out. So, and in this case, we're using the multiplication property of inequalities, which states that multiplying the same number, same positive number on both sides of an inequality keeps the inequality true. So multiplying the same positive number on both sides of an inequality keeps the inequality true, which means that the symbol in the middle stays the same. That less than symbol is still going to be a less than symbol. It changes when we're multiplying by a negative number, or when we're dividing by a negative number is when we want to change that symbol. But in this case, because this 3 was positive, we multiplied also by a positive 3. Okay, let's move on to exercise 2. Explain how solving 4x is less than negative 16 is different from solving negative 4x is less than 16. So let's actually solve those out in order to determine how they're different, and then I'll let you answer the rest of these questions. So if I'm solving out 4x is less than 16, because I want to get a 4 underneath this x for it to cancel out, I'm going to divide both sides by 4. Putting 4 underneath these numbers, both of these signs, means that I'm dividing them by 4. So 4x divided by 4, that's going to give me just x on the left side, 1x, but we don't show the invisible 1, is less than 16 divided by 4 is 4, And I didn't flip that sign because I divided both sides by a positive number. So there was no need to flip the sign. The signs on the numbers still stayed the same. But let's take a look at the other example. Negative 4x is less than 16. I'm not going to put just a 4 underneath it because negative 4 divided by 4 is negative x. And I don't want to have a negative. I want to have a positive. So I'm going to divide by negative 4. And then now I've got that x is x on my left side because negative 4 divided by 4 is 1x. And then 16 divided by negative 4, that's going to be a negative 4. And so this went from being a positive number to being a negative number. This positive 16 turned into a negative 4 because we divided it by a negative number. And whenever that happens, because the sign of the numbers changed, we also need to flip the sign in the middle so that less than is actually now read as a greater than. So our solution is different because when my number was positive, when the 4 was positive, I kept the sign in the same direction. But when the number was negative, I had to flip the sign because this positive 16 turned into a negative 16. And so for it to remain true, we also have to flip the sign of it. So hopefully that helps you answer those ones correctly on your first try. Don't just be guessing. Okay, exercise 3. Which inequality can be solved using the division property of inequality, where the direction of the inequality symbol must be reversed? So that division property of inequality, let me just go ahead and grab this real quick. That division property of inequality states that, just like the multiplication property of inequality, when we when we divide both sides of an inequality by a positive number, so dividing by a positive number, keeps the sign the same, keeps the inequality true. So there's no reversal when it's a positive number. But dividing both sides by a negative number the symbol must be reversed for the inequality to remain true. So if we divide by a positive number, then the sign stays the same. But if we divide by a negative number, then the symbol has to change. And so the symbol has to be reversed. So in this problem, we're being asked to choose out of these 5 options, which of them uses the division property of inequality, which means that we're going to be dividing both sides of the inequality to solve it out, and which of them also means that the symbol must be reversed. And that means that we're going to be needing to divide by a negative number if we're going to reverse the symbol. So you have to look at those 5 options and choose which one of them require division to solve out, and which one of them also require us to flip the sign when we do that division, because we're dividing by a negative number. Okay, I'm going to remove this. Numbers 4 and 5. So I get a lot of questions on this. So what numbers 4 and 5 and then 6, 7, all these table things want you to do? They want you to take what they're giving you is they're giving you a value of x. So they're saying use the table to solve the inequality. Negative 3x is less than or equal to 3. And then they give you these values of x. So negative 2, negative 1, 0, 1, 2. And then they give you this expression, negative 3 times x, which is the same expression as up here. What they want you to do here is they want you to take that negative 3x and then substitute these values in for x, and then whatever that equals, they want you to put it into the little boxes. So, for example, doing the first one for you, if my value of x is negative 2, and my expression is negative 3 times x is equal to negative 2, then negative 3 times negative 2 equals a positive 6, so I'm going to put a positive 6 there. And I'm going to do the same thing for these other 4 options. And then after you've done that, it also wants you to put the solution of the entire inequality here, which means you're going to include x some symbol, and then some other number in the solution. So it wants a solution of that negative 3x divided less than or equal to 3. It wants it in the solution part right here. So that, don't forget to consider whether you're going to be dividing by a positive or a negative number and what that does to the symbol in the middle.